Okay? If that will be exponential form, remember your z will follow the r e to the j theta, where your theta is in radians. It will follow that multiplying z1, z2. So if that will be in exponential form, it will be r1, r2, e to the j, theta 1 plus theta 2. Again, the theta should be in radians. And if that will be in division, it will be r1 over r2, e to the j, theta 1 minus theta 2. Okay? So if we're going to use the earlier, so theta 1 is 57.9946 times 1 pi over 180. Then our theta 2 will be 18.4349. So this is 1.0122 radians plus 0.3217 plus 0.3217. It will give you 3339, and converting back 1.339 to 180 over pi will give you 76.4267 degrees, which is the same 4295. As you can see, there are differences on the third and fourth decimal places. It's okay. In the division naman, it will be your theta. So it will be square root of 89 over square root of 10 e to the j 1.0122 minus 0.3217. It will give you square root of 890 over 10 e to the j 0.6905 pala. And your 0.6905 times 180 over pi, that is 39.5627 degrees, which is 39.55. So let's go to the logarithm. So we are going to use ln z. So that means ln of that complex number, and we are going to use z is equal to r e to the j. This is in exponential form. Why? Because we know that ln r e to the j theta will also be equal to ln r plus ln e to the j theta. And as we recall, ln and e are inverse, so that means ln z will give you ln r plus j theta. But again, your theta must be in radians. So if we have the example before, z is equal to square root of 89 e to the j 1.0122. Okay? So that means this is from z is equal to 5 plus j8. So ln z is equal to ln 5 plus j8. It will also be ln square root of 89 e to the j 1.0122, getting the exponential form. That means it will be ln square root of 89 plus ln e to the j 1.0122, and that is 2.2443 plus J 1012. So that is now our ln, say, exponential and trigono functions. E to the j theta is equal to cosine theta plus j sine theta. So what is the e to the negative j theta? It is equal to cosine theta minus j sine theta. You have to remember that. And this is your Euler's formula. Okay? So as you can see, we relate the exponential form of the complex number to the trigonometric function. As I mentioned earlier, just make sure that the exponential should be in radians, and yung theta in the trigonometric form can be performed through radians as well and through degrees. For example, we can say that e to the j pi over 2 is also be equal to cosine pi over 2 plus j sine pi over 2. Okay? Of course, if we're going to perform that cosine, it will not be cosine pi over 2. If you are in degrees in your calculator, it will be automatically be 90, or evaluating cosine pi over 2. We know that cosine pi over 2 or cosine 90 is 0, and plus j sine pi over 2 is 1. So the pi over 2 is in vertical, so there is no cosine. So the value of e to the j pi over 2 is what? J. Okay? So yun lang ibig sabihin nun. If it will be, of course, negative j theta, if that will be e to the j or negative pi over 2, it will be cosine pi over 2 minus j sine pi over 2. Pi over 2 is downward. So that negative y will give you, this is still 0 minus j, 1 ay negative j. Of course, it will follow that sine theta is equal to e to the j theta minus e to the negative j theta over 2j, and cosine theta is, and that is e to the j theta plus e to the negative j theta. Then of course, tangent theta is sine theta over cosine theta. Cotangent is cosine theta over sine theta. Secant theta is 1 over cosine theta, and cosecant theta is 1 over sine theta. How do we prove that it is correct? So sine theta is it equal to e to the j theta minus e to the negative j theta over 2j. Equal ba yan? So let's evaluate. E to the j theta is cosine theta plus j sine theta minus e to the negative j theta is cosine theta minus j sine theta over 2j. That is stated, we need to distribute the negative sign. That means, as you can see, cancel. Then it will give you 2j sine theta over 2j, proving that this is correct. Next will be hyperbolic. We are just going to evaluate forms. Then, as going back to trigonometric, sine h theta, and of course, we have cosine h theta. That means that is hyperbolic. We are just going to remove the j. So, that is e to the theta minus e to the negative theta over 2 e to the theta plus e to the negative theta over 2 as well. So, to follow again, tangent h theta is sine h theta over cosine h theta hanggang cosecant h theta equal to 1 over sine theta. Then, so if that is e theta is cos theta plus sine h theta minus sine h theta over sine h 2. Cancel, it positive, cancel 2 sine h theta over 2 is equal to sine h theta. Okay? So match. So next is inverse trigonometric function of complex numbers. Now that is arc sine z ln jz plus minus square root of 1 minus z squared. So for arc cosine z, it will be, sorry, this one is negative j, this is negative j also, ln z plus minus square root of z squared minus 1 for this cosine. Then arctangent z is negative j over 2 ln 1 plus jz over 1 minus jz. How can we solve that? We go first inside. So if we have z, edi solve the squared, then minus 1, then polar form, if perform square root or raised to 1/2. Then after that, solve natin siya, papunta dito, then saka nyo siya i-ln. Then, pag na-ln nyo na siya, saka nyo siya i-multiply sa j. So, ganun yung pagsosolve ng inverse trigonometric function. Inverse hyperbolic, that is arc sine hz. That is ln z plus minus square root of z squared plus 1. Arc cos z is ln z plus minus z squared minus 1. Then arctangent tan hz is 1/2 ln 1 plus j over 1. Again, to solve this, for example, you have z in rectangular. First, convert it into z polar. Why? Because you will use that here. This z, you can stand by it in z rectangular. Then solve it here in polar. Then convert it into rectangular. Then subtract 1 or 1 minus that z, new z in rectangular. Then perform the nth root. You will have two answers, isang plus at isang minus. So that is how you're going to solve the inverse trigonometric function. To follow in the hyperbolic, there is no j anymore here. So that means you will convert your z to polar, then add 1, then raise to 1/2, then you will add it and subtract it to your z, simplify them, ln, then you will have two answers for your hyperbolic sign problem. Any question?